examines various types of RAM and their power requirements, essential for optimizing computer system performance. It also illustrates the techniques for installing and removing RAM. Next, the video provides an overview of power supply components, such as the power jack and CPU power connectors, emphasizing their critical role in ensuring the motherboard functions correctly. In addition, it discusses the integrated circuits and capacitors positioned on the motherboard, underscoring how they stabilize and support the overall motherboard operations. The crystal oscillator emerges as a key player, providing clock signals essential for synchronizing motherboard operations and maintaining the system's timing accuracy. Moreover, PCI and AGP connectors serve as vital interfaces for hardware upgrades, facilitating the addition of external cards like graphics and sound cards to enhance the motherboard's capabilities. Proper CPU installation is crucial. Careful attention to alignment indicators, specifically the triangle, ensures secure and accurate placement within the socket. The video elucidates the straightforward process of removing and connecting RAM to its slot, a fundamental skill for upgrading or troubleshooting. Effective installation hinges on precise alignment. Continuing, the discussion shifts to the CPU socket and the power channels necessary for CPU operation, accentuating the significance of capacitors and inductors in efficient power distribution. The explanation of control signals generated by the CPU integrated circuit, IC, is vital for comprehending how CPUs manage power and performance, including the role of MOSFETs in voltage regulation. In terms of power distribution, the setup typically employs multiple channels using 2 or more MOSFETs to effectively manage voltage, ensuring stable power output to connected components. As the IC receives various signals, including clock and enable signals, it generates vital control signals for the MOSFETs, which is essential for the seamless operation of the CPU and other components. Additionally, the video explores the GMCH circuit, drawing parallels with the CPU circuit and highlighting the filtering capacitor's role, which is crucial for effective circuit design. Furthermore, RAM operates using 2 primary power types, VDD and VT, where VDD serves as the main power source, and VET is specifically designated for the RAM terminals. Various RAM types, namely DDR1, DDR2, DDR3, DDR4, and DDR5, each exhibit distinct voltage requirements. For instance, DDR4 typically necessitates a voltage of 1.2 volts. The roles of MOSFETs, capacitors, and coils come to the forefront, as these components are instrumental in managing power distribution within RAM, maintaining stable operation through effective voltage regulation. Capacitors are portrayed as essential filtering components in RAM circuits, stabilizing voltage levels by utilizing specific types for different circuit functions. The pivotal role of MOSFETs in RAM circuits is highlighted, demonstrating their function in controlling voltage flow and their critical connections necessary for circuit operation. The explanation of required input voltages for DDR2 RAM emphasizes the necessity of precise voltage levels, 1.8 V and 0.9 V, vital for optimal RAM performance. Moreover, MOSFETs significantly influence RAM circuit functionality by regulating current flow according to the voltage applied to their gate, making this understanding essential for effective RAM operation. The video discusses design flexibility in RAM circuits, where 1 or 2 integrated circuits, ICs, may be utilized to produce necessary voltages, influencing how VDD and VET are provided. Lastly, distinct types of RAM, including DDR1, DDR2, and DDR3, operate at different voltage levels, highlighting the importance of compatibility with motherboards, as each type has specific voltage requirements. The video underscores the significance of accurately identifying voltage levels in DDR2 RAM, particularly the critical 1.8 volts for power supply and 0.9 volts for VET, which are essential for functionality. Furthermore, the role of MOSFETs in powering RAM is elaborated upon, detailing their terminal structure and how they regulate current flow in accordance with voltage applied to the gate. Finally, the discussion encompasses various types of MOSFETs, including those with 3 and 8 terminals, emphasizing their operational similarities despite differing configurations, a crucial insight for electronic circuit design.